I've jumped over at the moment the probability chapters. They sort of fit together. I've jumped onto here. It's an easy and fairly quick one to do. So correlation is nothing completely new to you. What do you know already about correlation?
Positive or negative?
Positive and negative. Describe positive correlation. When what?
Can I draw on?
Not the moment, right. Okay, hang on. So, we've got one goes up as the other goes up. We've got... So it's about two variables now. Correlation, links two variables together. So far we've just looked at one variable data. We're now looking at two variable data. So positive correlation, you might have X and Y, and you'll do, what sort of graph is this supposed to be?
Line graph.
Well, a scatter graph, yeah. Okay? For example, a scatter graph, and that would show positive correlation because the only line of best fit there has a positive gradient. So we know what positive correlation looks like. But then if we look at this graph over here, what about the correlation on this graph?
Strong positive.
Strong positive.
Ooh.
Okay. So at A level, what we are doing is moving from positive and strong positive to actually quantifying the correlation by putting a number on it, saying how close the correlation is. So we've got positive correlation, we've got negative correlation, we might have that stumped you.
Well, what was that one with the curve?
It's not like, can I get a glass of water?
You could have non-linear, a non-linear relationship, but we don't have to worry about that one, so we're going to ignore that one. Okay, but you can have non-linear correlation. So positive correlation, negative correlation, and then somewhere in between the two of them, no correlation. Yeah, okay. Which is often the hardest one to draw. You're trying to sort of draw dots sort of at sort of random, really, but there's no relationship there. So that's supposed to be no correlation. Okay. Now what this chapter is all about, it's about quantifying the degree of correlation. Right, so we're going to measure correlation on a scale. Does anybody know what the scale is? And it's not 1 to 10. Negative something to positive something. Which fits. We've got positive correlation, negative correlation, no correlation. So yeah, if imagine you've got a number line, we'll have 0 in the middle. We will have positive 1 at one end, and we'll have negative 1 at the other end. So positive 1 would represent perfect positive correlation. Negative 1 would represent perfect negative correlation. And 0 in the middle, no correlation. But there's a whole... How many numbers are there between -1 and 1?
Oh, loads.
Loads. An infinite number, yeah. There are an infinite number of values between there. Okay? So what we're going to look at is how we can put numbers on them. And there are two methods. Now, has anybody done correlation yet in psychology? Okay, some of you will at some point. There are two methods. The first method has got a really long name. It's called the product moment correlation coefficient. or the PMCC for short. And it has its own formula. It's denoted by the letter R, which isn't particularly obvious, and its formula is this. No, it's actually in the formula books. Okay, for every x value, you take away the mean of it. For every y value, you take away its mean. You times those together for each data pair, and you add them up. And you divide that by every x value, take away its mean squared and add it up, times by every y value, take away its mean squared and add it up. And on the bottom, because we've got lots of stuff here, we got something squared times by something squared, which will give you something to the power of 4. And on the top we got something times by something, which is like squared. We square root the bottom to bring it back down. So the top is sort of quadratic and the bottom is. And that is a product moment correlation coefficient. So, this involves lovely tables full of numbers, which take ages to do in the exam. So I have one here, specially prepared for you, which is mostly done. It's just got some gaps in. Just so I know that you can fill it in. It will give you a number. It will always give you a number between -1 and +1. Which is a measure of the correlation. So, what we've got here is, if we just all listen for a minute, please. If we can just stay for a minute, please. So, what we've got here, if I just explain what's going on, imagine at the moment we've only got this bit on the left. We have got here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data pairs down here. 10 pairs of data. An X number and its associated Y number. Okay? 10 pairs of data. The numbers in the bottom and boxes are the totals. So if you look at the formula we've got, which was on the board a minute ago, see if I can get that top of the board, that formula there. We need an X minus X bar column, which is this column here, a Y minus Y bar column, which is this column here. The X minus X bar also needs to be squared, which is what that column is. The Y minus Y bar column needs to be squared, which is what that one is. And over here, the top line is X minus X bar times by Y minus Y bar. So you have all of those columns of data you need. Most of it is worked out. We will need totals for all of these to go down here in the boxes. Can you just have a go at filling in the gap numbers, the missing numbers, please? So the headings are at the top. Okay? X bar, I said there are 10 pairs of data here. They add up to 89. What's X bar going to be? 8.9. Yeah, 8.9. Okay, and Y bar is going to be 11. So if you can just have a go at filling in those missing numbers.